before we get started tonight, in the chat, if you can hear me, see me, if all that tech stuff is working correctly, drop in the chat 1 through 5 how you're feeling about this exam. We've got 2 days, count them, 2 days left until the AP exam. Who's excited? Let's get some AP Chem hype in the chat. All right, we're getting 4s. We're getting 3s, 4s, 3s. All right, awesome. Y'all are feeling good. 3.5, some 2s.
Ain't no 5s.
Ain't no 5, really. Where are the 5s at? A 3 is solid. A 3 means you feel okay. All right. So the big thing tonight.
Well, we need 1 5. Oh, 5, yeah.
There we go. We're getting 5. All right. Okay. I'm just gonna. Okay. 1 second. I'm okay. There we go. Sorry, someone was like spamming out 5s. All right. So tonight, the big topic of tonight. That's right. You all waited for it. We are talking all things FRQs, free response questions, the big scary part of the AP exam where you are put right in a problem and you are forced to solve it. So let me share the screen here. Here we go. Did that pull up correctly?
Yep,
awesome. All right. So, like I said, we're talking all things FRQ tips, tricks. We're going to do tons of practice. We're going to be looking at all sorts of problems. We've got some videos from Jahangir who will be talking to us later tonight. And yeah, let's just jump right in. And as we work through, Anu will be in the chat and I'll be in the chat talking to you guys, answering any questions you have while we talk. So let's get started. All right. So the first thing with are you here? Go for it.
Sorry. In FRQs, there's some in FRQ questions, a lot in every single question there are important words, and usually these words are bolded in the FRQ, and these are words that you definitely have to look out for very carefully, and specifically only answering these words. And in this section, we're going to be talking about those words, and we'll start off with calculate. For these types of questions, as you can see in the example, it says calculate the value of delta H for the reaction. For these types of questions, you need to show your work because you'll get points through showing your work, and you can't just have the right answer in the end, because if you don't show your work, you'll lose points. And you need to really be paying attention to your sig figs while calculating, and you also need to remember that you need to include the units with your answer. And also make it easy for your reader to find your answer, find your final answer. So you should just like circle it or box it so that they can easily see it. And you just basically need to show your work completely just to make sure that you're getting all the points possible. And our next word is describe. Describe will be bolded too, I believe. And an example is describe how you would prepare a 0.25 M solution of KCl. You should basically strive to show that you understand whatever you're being described. And remember, always write in, I believe you had to write in complete sentences, right? Throughout the in described questions, you got to write in complete sentences, and you should also try to make sure you provide a concrete example after your description of the topic or the question. And also, please make sure that your handwriting is legible, because as long as it's legible, as Dylan said in the chat, if it's not legible, you don't want your hard work going to waste. So just make sure that if you can read it, someone else probably can read it. So try to reread it, your answer was in case, just to make sure it's legible, as Dylan said in the chat. And our next question type would be evaluating a claim. So sometimes they'll include questions where they say X person claims X, Y, and Z, and basically they'll ask you to either agree or ask you whether you agree or not with the claim. And usually you need to justify your answer using information that they provide to you. This is they won't like specifically evaluate a claim, but this is like a type of question they'll include. And it isn't very common in chemistry, but it might occur. It might be in the FRQ. And basically, in these type of questions, you need to state whether you believe it's true or not using the information that they give you and your background knowledge. And you need to make sure that it's at least 2 sentences up to 4. And remember, for these questions, you don't need to write essays. Make sure that you're getting to the point immediately because you don't have time to write essays. And to be honest, you probably will be like kind of like distracting the reader, the scorer, by having all these sentences. So just get to the point, make sure you're just writing the answer down, and make sure that your handwriting is legible again, because they need to be able to read your hard work.
I think I have a tip here too, and that's that typically when they're asking a question like, do you agree with the student's claim? It's typically because if you disagree, it's not because typically it's not because something went wrong in the lab, unless they very clearly say like, justify why they would have received these results. If they're making a claim about like the chemistry of something, typically you have to respond with like, this is your opportunity to show off your like theory knowledge. For example, with this problem, one might say, I disagree with the student's claim because, and your answer wouldn't be like, I would rather use this. It should be because the pKa of bromophenol blue is different from the pKa of whatever. And yes, you should always say, I agree or I disagree. Be clear with your answer and justify it with actual data or chemistry. So it should basically I like to answer these questions using like kind of like an ACE method where you have your answer, you cite some evidence of why, and you explain why that evidence backs up your agreements or different disagreements. So whether that's pointing out a specific principle or law like Le Chatelier's principle, or pointing out why you disagree because the K value is too small, or I don't know, because this reaction would not proceed as fast as they say, whatever. But you have to justify that with actual chemistry, whether that's math or whether it's like theory. And in your calculations, you should include as much as possible. So full molecules, like don't use shorthand because they don't know what that shorthand is. And I would say go in the order of state your claim and then explain, because the first thing they're looking for is a correct answer, where these are never like subjective questions of, well, I might agree, but like there's typically something fundamentally wrong with their answer if you disagree. And so I would say agree or disagree and then explain why, as opposed to doing the opposite, because the first thing a reader will be looking for is that agreement or disagreement, because if they see the wrong answer, they're going to move right on. That's kind of the big thing there.
And our next word that they'll probably bold in your booklet would be identify. And this is another type of question. And usually they'll ask you, like, identify the cathode in a galvanic cell. So basically, in these type of questions, make sure that you're doing exactly what the question is asking. So carefully read the question and make sure that you're doing exactly what they're asking. Like if they're asking you to circle a compound, make sure you're circling a compound instead of like boxing it or marking it another way. And usually these types of identify questions are really the easier questions usually. And these questions are basically pretty straightforward. So these are probably like really free points that you can get on the FRQ section usually. Not guaranteeing, but usually. Sometimes you will need to provide reasoning with your answer, and usually you need to make sure it's about 1 to 2 sentences long. And you need to make sure you're identifying what is asked, because you'll usually get a point for identifying it and usually up 1 point for explanation. So even if you're unsure about the reasoning, just get that 1 point for the identifying.
Yeah, and these questions, I actually really like these questions because they're very straightforward. They don't feel like they're mind games like other questions. When you're talking about an identify question, you typically know what you're identifying, and from there you can explain why you identify what you did. And so they're typically the easier questions, like Shreya said. And they will ask you to identify and explain. Shreya, correct me if I'm wrong, you should always explain, But if it says just identify, like if it's asked like circle the species that is the oxidizing agent, whatever, you don't have to explain, right? Correct me if I'm wrong. You should
I think you
always
don't have to
explain, but I think like there's an FRQ I remember where it was like draw a dashed line identifying a hydrogen bond somewhere in this like particulate diagram. You didn't have to write like this is a hydrogen bond because blah 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 blah. All they needed to see was the correct dashed line. Again, correct me if I'm wrong, but that tracks, right?
I think when I was doing AP Chem, my teacher like usually just gave me the point, like in school, just gave me the point if I just identified the answer. And usually, but what I always did, like, and I still always do even in AP Bio, is that when I identify the answer, I usually like just continue saying because and write like a couple like because and finish the sentence off with a short explanation. So I think it's always like safe to just put a short explanation, but I think they'll only give you the point. I think they'll give you the point even if you just identify. But I don't think it'll hurt if you spend like an extra like 10, 15 seconds writing the explanation.
It won't. And typically if you explain it, well, I would be careful though, because if you're confident on your explanation, go for it. If you are wrong on your explanation, that might, I don't know if that'll hurt you, but it might. So my advice would be make sure that you're confident in your explanation. And also, honestly, explain it to yourself, if anything. If you can't explain why you're making the decision you're making, odds are you should at least be thinking more into it. For example, if it says like, here's an electrolytic cell, or pardon me, a galvanic cell, they're like, circle the cathode, yeah, it's a 50-50 shot, but you should be able to say like, okay, I am circling this because the cathode is where where oxidation occurs or reduction occurs, and even if you're wrong, if you go, well, the cathode is where oxidation occurs, so I'm going to circle this, at least you've kind of justified it to yourself, and so if it helps you feel more secure in your answers. Anyway, I'm going to pass it off to Anuva now.
Hi, everyone. Yeah, thank you. So I also wanted to just say something for the last one. I'm not sure if you mentioned it, but if you get the incorrect answer for a previous part, but then continue to do like the right, I guess, steps building up to it, then it will still count as like partial credit. You'll still get partial credit for it, but you'll still get it wrong technically because you'll get like a point off because the previous answer was wrong. But we can go on to justify. Or are we on identify? I'm sorry. Yeah, okay, justify. So justify for this example, we're saying like which acid is stronger, HNO3 aqueous or CH3COOH aqueous. Just like a pop quiz question. If someone could name that acid in the chat, that'd be cool. But anyways, the question is justify your answer based on the particulate representation above. So these keywords are usually paired with a diagram, model, or background information, but they're not always. And so, for example, for this question, it's justify your answer based on like the particulate representation above. So they'll give you a model of a particulate diagram. And you may also be asked to represent reasoning, explaining how your evidence supports, defends, or modifies the claim. So you would have to, for this justification, also add an explanation. Yeah, Dylan, you have to justify why now. And then this is like another form of saying like describe or explain. And then, but the more specific thing about this one is that you have to explain using the data that's currently like given to you and the concepts from like AP Chemistry, whether it's pulling from one unit or pulling multiple units and connecting that with the diagram or the model. And you want to typically write 2 to 4 sentences when you get one of these parts. Andreas, did you want to add anything?
I think you covered it all. And just make sure that again your handwriting is legible. If you can read your handwriting, that's probably good enough.
Yeah. I did see that Dylan said that you're only allowed to use pen. I think we had gone over this in a previous night. They say pen so they can like actually like read it, because sometimes when you use like graphite, like it will smudge off and then like some of your words will like disappear within like transit, or like just even like rubbing against the other page when it's like your booklet is closed. And also some people tend to like write really like lightly on their exam, but last year when I took the AP exams, like they allowed us to use pencil, but yeah. Is anyone having issues hearing me?
I can hear you fine. I'm not sure.
Okay.
I hear you. Okay.
Okay. So now we'll move on to calculator tricks. So I have a TI 84 plus CE. Shreyas, which one did you have?
I have the TI Inspire. So I don't have the
Oh, am I
regular
like cutting
TI
out?
80. I can hear you fine, but I'm not sure
I hear you
why is
okay,
it
yeah.
cutting out for other people.
Okay. Yeah, I have this calculator, guys, the gray one.
Oh, someone else has a TI Inspire. Yay.
Okay, so we can go on to use the calculator.
Okay, I can
Shreyas, do you want
I
to
can hear
start
you
with it so
fine.
then I can, let me try using different headphones. Oh,
Okay.
okay. People are hearing me
I
fine.
can hear you
Okay.
fine. I think people can hear you fine, I think. Because I
Okay.
can
I
hear
think
fine.
I think it's just a few.
Okay. All good. Okay, so if we can move on to the next slide. So if everyone has their calculator out, we can do these together. So yeah. I think we're going over how to use the equation feature and also the unit converter. So yeah. Dylan, do you want to move on to the next slide? Okay. So we're going to use the solver function. So for this one, you press math, and then in order to quickly get to it, you can press alpha B, or if you press like the up key once, then it will go to B. So on my calculator, it says numeric solver, but on the example, it just says solver. So if you click on that one, it'll bring you to like this page, which is also the second diagram that's over there. And I believe these are for TI 84 plus, but Shreyas can go over it. Did you have a TI Inspire, you said?
Yeah, I can go over that.
Okay, so we
So
can do it with
basically,
that too.
so first, is it going to show it inversely? Like, that's really sad if it does.
You could just like talk it through.
I'll talk it through. So you go make a new page, make a new document, or you can just go into your calculate section of your calculator. If you go into the calculate section, then you'll have you press your menu button, and then you go to number, which should be 2, and actually I lied. You go to algebra, and then you press number 1, which is numerical solve, and then it should say, you can't read it, but like it'll say n solve, and then it'll give you brackets. Then you type your equation. Here in the example that's on the screen, it says 2x plus 6. Then you can do 2x plus 6, and then we want to see what x equals when 2x plus 6 equals 10. So then you just put equals 10, and then you do comma x. You're not gonna see it, but I'm just gonna type in the chat what it should say. Y'all know what I'm talking about. It should say that, and then if you press enter, it'll tell you what x is. It's not going to show on the screen, but it says 2 for me.
Yeah, so for my TI 84 gang, you literally put it in just like how the diagram says. So for the 2x plus 6, and then for the E2, you put 10. So just like pretend like E1 is one side of the equation and then E2 is the other side. And then for the third one, it should bring you to that screen, and then make sure the bounds are like very far apart. So like you're not solving in a specific bound. And then for x, when you like go onto the x area. Actually, I realize you can't really see that. Then you press alpha, enter, which is solve, and then it will show up in the x value, what the x value should equal. If you have a different calculator, you can probably look on YouTube how to do it. Obviously, like we're not going to go over every single calculator because one, that's going to take a long time. Two, I don't have all of those calculators. I only have a DI-84 plus VE. But yeah. And I believe I saw something about will a scientific calculator be fine on the test? So a scientific calculator should be fine. It's just that a TI-84s have like this these like fancy functions. But again, you could always like do them partially by hand with algebra and then it should be okay. We can move on to the next slide where we can go over the metric conversion. So on the TI-84 plus CE, or I believe just even the TI-84, you press the apps key and then you use the scroll, so like this area, the arrows, and then scroll down until you can go to, you see like sci tools. So on mine, it is 0. And then you select it, and then you'll see the second screen, which says Texas Instruments, and then just press enter again. Or then from here, you can either pick like sig fig calculator, unit converter, data graphs wizard, or vector calculator. And you can just press unit converter. And then you have a ton of like options to pick through. So like you have 12 options on here. So like, for example, if we're going to pick length, then you can choose like you put what type of what like unit what you want to convert. So if you say like 1 centimeter, then you can convert it to like feet, for example, and then you click feet, and then it will tell you like how much 1 centimeter is in a foot. So yeah, Shreyas, do you want to go over how to do it on your TI Inspire?
Okay, guys. So it's not that complicated, but like it might sound a little bit. I don't really. It might be a little daunting. So first, just go to your regular calculator screen. You're not gonna be able to see that, but like, go to your regular calculator screen, and then there should be this little booklet here. There should be a little booklet there, and you click on that, and then you'll get to a page. You should get to this new screen, and on the top of the screen there should be like a 3 which has like a Fahrenheit slash you're not gonna be able to see that, but like a Fahrenheit slash Celsius like symbol. So and it should be page 3, and if you click on page 3 you should see the first thing saying conversion assistant. Once you click conversion assistant, you'll be able to convert from the units to whatever units you want. So I'll do like length. The first one will be length in the category list, and then I'm going to be like from meter, not like from meter to centimeter. And then you'll have like this type of screen. If you're doing what I'm doing, I'm just gonna type in the chat, to be honest.
You don't need to download any apps for this. This comes with your calculator. If you might not have do you not have the TI-84? Because I believe it should be on your calculator. Like personally, I didn't download anything. But yeah. And then you won't necessarily have to convert from Fahrenheit to Celsius. It's usually just Celsius to Kelvin.
And I put whatever you should see after you get to that point in the chat. And then you can input the numbers you want there. I'm going to say like 10 meters.
Okay.
Yeah.
I would probably look it up why you might not have those, because like I have a TI-84 plus CE and I didn't have to download anything. But yeah, so I know one thing
Does it
isn't on
depend on
there.
the sorry?
Oh, go ahead, sorry.
Does it depend on like the version?
I don't believe
Is
so
that like
because
an
they're
older
saying they have
version?
the same as me.
Okay. Yeah.
Okay,
So that's
so
how you do it on the TI Inspire, but like if you guys still don't like if you guys it's a little hard like hearing it from like me saying it, like there's also great YouTube videos.
yeah, definitely if you like didn't really get what we were saying about it, you could always look it up on YouTube and they have very helpful videos about it. And one
You can just search it
tip,
up.
not tip, one app that I know is on at least the TI-84 plus CE is the periodic table. I didn't add a slide for it, but if you simply just press apps and press 7, which is periodic, then you have, it leads to the Texas Instruments screen. Just press any button and then you can see like the whole entire periodic table. It on my calculator at least it doesn't show like the labels for them, but if you like hover over it, it will say like which element it is. And for example, like if you take carbon, it will show like the atomic number, symbol, weight, and a bunch of like helpful things about it. It even shows the electron configuration, which is really helpful. So, yeah. Yeah.
That's very cool.
So, again, if you forget, you could always look it up. But yeah. Okay, so we can probably move on to
I don't
the
think there's a
FRQ.
periodic table in the TI Inspire, which is making me a little jealous. I'm trying to find it and I'm trying to search it up.
Yeah, still learn the stuff,
But it doesn't.
guys. Don't rely on it.
Yes. Yeah, don't rely on it.
Because sometimes it takes like a little bit of time to get to it and all of that. So, yeah.
Yeah, and you don't have time.
Okay, we can move on to the FRQs. So, our lovely host, Jahangir, who isn't here, he made these videos for us. So we can go over the first FRQ and then it's around 20 minutes, but yeah.
Just let me know in the chat or a new Trace. Let me know if you can't hear it because I might not have shared my computer volume.
Cool.
All right, so let's look at this FRQ question. We have aniline, which is a weak base that reacts with water according to the reaction represented above. Now, question A asks us to find the equilibrium constant expression, that Kb, for the reaction represented above. Well, this question is one of those questions where it's an easy point. You can get this point by just looking at the AP chemistry formula sheet. And to find our Kb, that equilibrium constant, it's just our OH, and that is multiplied by our conjugate acid all over our base. So if we look at the reaction above, we can already write our equilibrium constant by just looking at the formula. So we have our OH on the product side multiplied by our C6H5NH3 plus, and we can divide that up by our aniline, which is C6H5NH2. Now we can forget about water because water is in this liquid form while we're in the aqueous form. So that's our Kb right there, and that's our answer for question A. Let's look at question B. Question B states a sample of aniline is dissolved in water to produce 25 milliliters of a 0.1 molar solution. The pH of the solution is 8.82. And it asks us to calculate the equilibrium constant, that Kb, for this reaction. Well, to start, let's break down what we're given. and we're given the pH, and the pH is 8.82. We're also given the concentration of aniline, and the concentration of aniline is 0.1. And that'll be useful when we're calculating an equilibrium constant. All right, so we have pH. Now, how do we get to getting the concentration of our OH and the conjugate acid for aniline? Well, we first have to start by looking at the equation of POH equals 14 minus pH. And that's how we find our POH. And since we're dealing with bases, we need to find our POH. And that's pretty simple. All we have to do to find our POH is 14 minus 8.82, which will get you 5.18. Alright, so now we have our POH. Now what are we supposed to do? Well, if we remember our equations from Unit 8, we know that POH is equal to negative log of the concentration of OH. So if we want to find the concentration of OH, all we have to do is move the negative and do the inverse of log, which is a power of 10. So our concentration of our OH will be 10 to the negative POH. So all we have to do is do 10 to the power of negative 518, and that'll get us 6.6 times 10 to the negative 6. Now from here, we need to find our conjugate acid, that concentration for the conjugate acid of aniline. Now, all we have to know is that the concentration, or the concentration of the conjugate acid for aniline will be equal to the concentration of OH. And both of them will just be 6.6 times 10 to the negative 6. Now here's the equilibrium constant we found in part A. So all we have to do is plug in our numbers. So our OH and our conjugate acid for aniline was 6.6 times 10 to the negative 6. And we could just square that since we have both of those numbers. And we were given the concentration of aniline, which is 0.1. And if you do the math, we will get 4.4 times 10 to the negative 10 as our KB. And that's the answer right there. Alright, so let's look at question C. And question C states that a solution prepared in part B is titrated with 0.1 moles or molarity of HCl, and we need to calculate the pH of the solution when 5 milliliters of the acid, the HCl, has been added. Now to answer this question, we obviously need to look at information from part B, and to do this, we need to find the moles of aniline specifically, and the moles of HCl. So to do that, all we have to do is remember the amount of volume that we had for aniline, which was 25 milliliters or 0.025 liters, and we need to obviously multiply that by 0.1 m or 0.1 moles, and we will get 0.0025 moles. Now the reason why we're doing this is because the equation m equals n over L, and we're trying to find our moles, that n part, so we multiply L our liters, that cancels out, so that's how we get our moles. And we need to do the same for the HCl, and for HCl it's going to be 0.005 liters because you're converting milliliters to liters, and we multiply that by 0.1 molarity because that's our concentration that was given, and we get 0.0005 moles of HCl, and over here is that aniline that we were talking about. Now, if you remember from past units, when we write this equation, which is the C6, or the formula, which is C6H5NH2 plus HCl, and we're going both directions because this is a weak base, So we have to go both directions, and we're going to have C6H5NH3 and now next we need to set up our reaction. We need to show our reaction in order to set up ice tables. Now, if you remember from past units, we have to take out the specter ions because we need a net ionic equation in order to set up our ice table. And what that would look like is we have our aniline NH2, and we have hydrogen ions, or just hydrogen, and it goes both directions because we have a weak base over here, and that makes our conjugate acid. Now, as you can see, we removed the chlorine because our chlorine was our spectator ion, and now we can set up the ice table. So we have initial, change, and equilibrium. In our initial, we have 0.0025 moles for our aniline, and for our hydrogen, we have 0.0005 moles, and for our conjugate acid, we have 0 for initial. Now, for change, we always want to look at the limiting reactant. We always want to see which one is the smallest number, and we want to subtract it from the aniline and add it to our conjugate acid. So obviously, it's the hydrogen, and it usually is the hydrogen, and for bases, it's usually the OH. So it's going to be minus 0.0005 over here, minus 0.0005, and over here we're adding 0.005 because whatever we do here, we do the opposite on the product side. So what we end up with is 0.002 moles of aniline over here. For our equilibrium for hydrogen, we always have 0, and for our conjugate acid, we have 0.005 moles. Now from there, we need to find our molarity, and all we need to do is get our concentration. So if we want to find the molarity of aniline, that concentration for that, we get it 0.002 moles, and we divide that over 0.03 liters. Now you might be asking, why are we dividing aniline by that amount of liters? Well, it's because that is the total amount of liters of volume that we have from HCl and from aniline. You see 0.25 plus 0.005 gives us 0.03 liters. And if we divide that up, we get 0.0667 moles for our aniline, and we need to do the same for our conjugate acid of aniline. So we do 0.005 moles over 0.030 liters, which gets us 0.0167 as our concentration for the conjugate acid. Now from here, you can go one of two ways. You can set up another ice table and make that equal the equilibrium constant, or you can use a Henderson-Hasselbalch equation, and that is given on your formula sheet, and that is POH equals PKB plus log, and for our instance, we're having our conjugate acid, which is C6H5NH3 plus over our aniline, which is C6H5NH2. Now from here, we don't have our PKB, but we can remember that the PKB equals negative log of our equilibrium concentration. So we can just plug that in there, and we know our equilibrium concentration. So POH is going to equal negative log, and then from, if you remember from part B, we have 4.37 times 10 to the negative 10, plus we have log of those concentrations, and we found that to be log, and over here it was 0.0167, and we divide that over 0.067, and our POH, that negative log, is going to equal negative or positive 936, plus we have log 0.25, which is going to equal 8.76, and this is our POH. We need to find the pH, and pH is going to equal 14 minus POH, so that's going to be 14 minus 8.76, which is going to equal 5.24, and 5.24 is our pH. For those of you who are interested in the second route, here's what that would look like. We set up another IS table and put the concentration of aniline and the initial concentration of conjugate acid. We don't have the initial concentration of OH, we leave it as X. Then we plug it into our equilibrium constant, and this was found from part B. So we just plug that in, and we find that our X, or our OH, is going to be 1.7 times 10 to the negative 9th power. And from our formulas, we have POH, which equals negative log 1.75 times 10 to the negative 9th power, and we get 8.76, and then 14 minus 8.76 is 5.24. So as you can see, we still get the same answer, but over here you do a little bit more work, and when you do a little bit more work, you sacrifice time. And in the AP Chemistry test, especially in the FRQ section, you don't have a lot of time, so you can't sacrifice as much time just to find the same answer when you have a second route. So always resort to your AP Chemistry formula sheet, because on that formula sheet, there are some formulas you can use to solve the question faster and easier. Question D states, calculate the pH at the equivalence point of the titration in part C. Well, we know that our equivalence point is going to equal the moles of our aniline, which is C6H5NH2, and that's going to equal the moles of the hydrogen ions. And this is because we're dealing with pH, not POH, so that's why we're referring to the moles of hydrogen ions. We're making that equal aniline. So now all we do is set up our reaction, which is C6H5NH2 plus our hydrogen ion, and that's going to go both ways because we have a weak base. So it's going to be C6H5NH3 for our conjugate acid, and we yet again set a ice table up, and our initial for C6H5 or our aniline is 0.0025 moles if we refer back from part C, and our hydrogen ions will also be 0.0025 moles, since we said the equivalence point is moles of aniline equals moles of the hydrogen ions, and the conjugate acid will be 0. So since we're trying to find the equivalence point, we subtract 0.0025, and we subtract 0.0025 over here. So our equilibrium is going to be 0 for our aniline, 0 for our hydrogen ions, and over here we're going to be adding 0.0025. So the conjugate acid, the moles will be 0.0025 moles. Now, if we refer back to part C and the question, it literally asks us to calculate pH at the equivalence point of the titration. And the titration that we're given in part C was 25 milliliters, and it was 0.1 for the molarity of HCl. So with that in mind, that is the equivalence point. This volume, 25 milliliters, is our equivalence point. So the total volume is obviously going to be 50 milliliters, and we divide that by, or we divide 0.0025 by 50 milliliters, so that'll be 0.0025 over 50 milliliters, which would be 0.05 liters, and that'll get us 0.05 for the concentration of our conjugate acid. Now from there, we yet again set up another ice table. So we have C6H5 H5NH3 plus, going both ways since we have a weak base, and we have C6H5NH2, and we have our hydrogen ion on the product side. So we basically switched it up, and we already have the concentration of our conjugate acid. So we set up ice table, and this is going to be 0.05 m, and over here is going to be 0, 0, since we weren't given the moles or the concentration. And since we don't know the x, we don't know what the change is, we do minus x. Over here it's plus x. So this is going to be 0.05 minus x, and that's going to be our equilibrium concentration for our conjugate acid. And over here it's going to be x, and x as well for the hydrogen. So if we look back to our equilibrium equation, or the constant that we found that it was the... Now when we're solving from here, we obviously have a different equilibrium constant. Instead of Kb, we have Ka. We need to find our Ka, and to find our Ka, we do Kw over Kb, or the equilibrium concentration when water is in self-ionization, over the equilibrium concentration of our base. So that would be 0.01 times 10 to the negative 4, and the Kw is on your formula sheet, so it's going to be 1 times 10 to the negative 14th power over 4.4 times 10 to the negative 10th power, and we found that from, I believe it was part B. Now it was 4.37, but we can just round up, it's fine. And that'll be 2.3 times 10 to the negative 5th power, and that is our Ka. Now from there we need to find our Ka formula, and Ka is going to be our products of our reactants, so that's C6H5NH2, or our aniline, times that hydrogen ion, and we divide that up by our conjugate acid, which is C6H5NH3 plus, and that'll basically be 2.3 times 10 to the negative 5, which equals x squared over 0.05 minus x. Now the x squared came from our concentration because we don't know x, and just x times x is going to be x squared. So, and over here we're going to divide that by 0.05 minus x because that's our concentration for our conjugate acid. And when we plug that in, when we find our x is going to be equal to 1.1 times 10 to the negative 3 moles, and that's going to be our concentration for the hydrogen ions. And from here, to find our pH, we know that pH is equal to negative log of our hydrogen ion concentration, and that pH will equal negative log 1.1 times 10 to the negative 3rd power, and our pH will equal 2.96. And there you go. Our pH is 2.96. And this will come important in the next question. Alright, so now let's look at question E. And question E states that the pKa values for several indicators are given below. Which of the indicators listed is most suitable for the titration, and we must justify our answer. But looking at part D, we know that our pH is equal to 2.96. And if we remember from Unit 8, the pKa is basically the sum, the pH is the sum of the pKa. So the indicators for the pKa, that indicator is going to show us at what pKa the color will change. And most of the times our pKa will basically correlate to our pH. So the indicator that'll best suit our pH will be erythrosine. And here's our justification. Since the pH at the equivalence point is acidic, the best indicator is erythrosine. Since the pKa value is the closest out of all of them, you see how litmus is 7. I'm not even trying to pronounce that one, but it's pretty basic. So erythrosine is the one that's acidic, and it correlates to our pH. It correlates the most to our pH. So that's why erythrosine is our answer for our indicator.
All right, so I would suggest that we should take a slight breath after that question.
Definitely.
Yeah. So I just want to make a quick note here. That was a bulky question. Let me try my video here. So I was looking through the answer for this question. This was from the 2003 AP exam, and it was heavy. This was a heavy question. So I think before we move on to the next question, I think it's worth just having a little talk about, like, you know, Anuv and Shreyas, like, what are your guys' tips for if you open up the AP exam and you see this 5-part beast where each problem feels like it's its own FRQ? You know, what do you guys say that you open the exam and you see this for question 1? You know, because this is a valid question 1. You could see a problem like this on the exam. So
Personally, I'd usually just skip it and go do it last because I don't want to feel that stressed out in the beginning. That's how I feel. I just like skip it and do it last. Like the smaller questions first because like it ease me.
I just posted the link in the chat and it's number 1 on that one. But I actually would say the exact opposite, to do like the chunkiest questions first, because it's like I want to get the big ones out of the way, and then usually like I feel like the shorter FRQs are easier for me. But with these questions, definitely read all of the information and then take it one step at a time. Yeah, like they're complicated sometimes, but usually like it will be broken down within each step. You guys got this. And also make sure you balance that equation, because sometimes they won't balance the equation for you. So
that is a good tip.
yeah. But yeah, make sure the equations are balanced. Take it one step at a time. What I like doing is I like, for like the first part, writing down all of the information that we have, and then with that information, just continue to what the question is asking. For example, like for this one, I would write the KB expression because the question is asking for the KB expression. So yeah.
I think also I like to treat these problems kind of like stories where the parts like build on themselves. And so, you know, like it feels like you're working through one big problem, which feels like, I feel like it actually makes it feel smaller, because if it feels like you're working through 5 giant problems, it's like, it doesn't feel like they build on each other. And I want to note, correct me if I'm wrong here, but on the AP exam, if a part requires an answer from another part, if you get that first part wrong, but you get the second part right relative to your wrong answer, you still get the point, right?
So
Do you get consistency points? I know on like econ you do.
I believe so, but I saw someone, I think Grant, say it that College Board might be trying to move away from that. But for at least for like all of these, when I was looking at the scoring guidelines, they do say like if the previous answer is wrong, but all of the steps that you take for this certain part is right, then they will still grant you the point, or at least partial credit.
Yeah. So I would say, like, don't dwell on, if you get an answer for one part and if it's relative to the second question, use your answer and imagine that your answers are 100% right. Like, don't be like, oh, well, my answer for this was this, but I thought it was this, so let's use 2 different numbers. You're setting yourself up for like double bad time. Right. So just be consistent. They're called consistency points. Be consistent with your answers. Is a big tip, which I think in this problem is especially relevant, because you were using the KB for this and the answer for here, and so it's all relative. All right, and so
You
for the
guys
next
got this.
for the next question, we are going to be like pausing each time and give you guys probably like 2 or 3 minutes, I think, right, per
Mhm.
part, to give you guys a minute to like sit down and think through this problem and situate yourself in the problem, so that when you see Jahangir talk about it, it doesn't just feel like you're thrown into something. So
Yeah, and then
Consistency.
afterwards, I will also post the scoring guidelines that are corresponding. So yeah.
yeah, this one is a bit more. I'm also just going to check what year this is from, because it's an equation that I need to look at. All right, so who's ready for the
Also,
second question? Oh, Shreyas,
just
sorry.
remember, guys, like this is everything that you know everything. It looks intimidating, but you know it. You like,
Yeah, well,
it
all
looks
these part,
intimidating, you know
all
it.
the questions are from the curriculum, so it's they're never going to throw you something that like was not fair game, or that like wasn't necessarily covered in your class, assuming you covered all the material. You know, like everything is solvable with the material you've learned. So they're never going to be like, oh, well, if you didn't learn this obscure little thing that we never told you thing, but it's like tangential. If they haven't told you about it, it's not fair game. Like they're very cut and dry with it. Every question on the exam is like perfectly, like I think they're like required to align every question with a specific theme or unit or like skill. So that's the idea there. All right. So let's move on to question 2.
Let's look at this FRQ question. It says that the combustion of carbon monoxide is represented by the equation above, and question A asks us to determine the value of the standard enthalpy change, that delta H of the reaction, for the combustion of carbon monoxide in the gaseous form at 298 Kelvin using the following information. Well, right now it's giving.
All right, so I'll give you guys a few minutes to work through this part.
For those who are saying that it's too blurry, oh, someone already posted it, but it's 2006. It's the second question, so yeah.
All right, y'all, that is 2 minutes. We're going to give you 2 minutes for each question. That is not representative of the exam. It's just to like keep things moving throughout the exam. So don't worry if like in those 2 minutes you weren't able to get the full answer. It's just so we can keep this moving. Also, yeah, the formula sheet for 2006 is wild. Just remember that there are some equations on here that you no longer need to know or aren't necessarily like explicitly tested. Like I see the Arrhenius equation on there. That's like not explicitly tested anymore. There's a handful of others. So don't freak out that this is like a little wacky, like the Nernst equation is on there. The equations on your equation sheet, that's like 95% of the equations that you'll be using. So don't freak out. Anyway, let's take a look at the question.
Giving us 2 equations of the reaction is showing 2 different reactions and showing different enthalpies, different standard enthalpies. So by now, you should have identified that this is a Hess's law question. And well, every time I see a Hess's law question, I always think of it being like a puzzle, solving a puzzle. So this is basically like solving a puzzle. We're using both these reaction equations to form this equation above. So all we can do different things. We can switch the CO to the reactant side and switch the carbon and then oxygen gas to the product side, and that'll make this 110.5 standard enthalpy in the inverse direction. So that'll make it positive instead of negative. And since our carbon monoxide is on the reactant side, let's do that real quick. So we're making this inverse. We're moving the carbon monoxide to the product side, and we're moving our reactants, our previous reactants, to the product side, which will make our standard enthalpy positive 110.5 kilojoules. Now let's look at the second reaction, second equation that we're given. And the most noticeable one that we're given is CO2. And CO2 is on the product side in our final reaction. So let's just keep that the same. We have carbon plus oxygen in the gaseous form is carbon dioxide. All right, so now let's cancel out our, we need to cancel out the carbon and the carbon, so we take that out, and we want to cancel the oxygen. It's every time you see when you cancel, when there's a element on one side, like the product side, and there's another element on the reactant side, we cancel that out. And since we see that carbon on the first reaction, the first reaction equation is on top, and on the next one it's in the reactant side, we cancel those out, and same as oxygen, and 1/2 minus 1 is just going to get you 1/2. So our final equation will mirror the equation above, and that means we did well. We solved the puzzle. And I forgot to label this here, but our standard enthalpy is going to be negative 393.5 kilojoules, since we're keeping that the same. And if you solve that, you will get negative 283 kilojoules as your answer for the combustion of carbon monoxide. So there's your answer right there. Now let's look at question B. And question B states to determine the value of the standard entropy change, that delta S of the reaction, for the combustion of carbon monoxide at 298 Kelvin using the information in the following table.
All right, so another 2 minutes. And if you need to, I think Anuva dropped the question in the chat. So if you need to go back and like reference the equation, feel free to do so. On the exam, you'll have the whole question. So yeah, I know here it's a little bit truncated. All right, y'all, that is 2 minutes. Let's take a look.
Well, for a question like this, we really don't have to do much. We just need the equation for the standard entropy change, which was the entropy of products. entropy of products minus the entropy of our reactants. So let's refer back to the chemical equation we had before, which was carbon monoxide plus 1/2 of our oxygen gas, and that goes into carbon dioxide. So using this equation and using our chemical equation and the equation for finding the standard entropy change, we can just plug in our values. Since we have carbon dioxide as our products, we can put 213.7, and we subtract that by, and as you can see for the oxygen, there's a 1/2 coefficient. So we have to remember that we have to multiply 205.1 by 1/2, and we add that to our carbon monoxide entropy, which was 197.7. And the reason why we add those is because they're part of the reactant side. And if you do the math, our standard entropy change will be negative 86.5 joules. And that's your answer for question B. Now let's look at question C. And question C states to determine the standard free energy change, that delta G, or our Gibbs free energy, for the reaction at 298 Kelvin, and include units with your answer. Well, if we remember the equation for...
All right, you know the drill, 2 minutes. All right, y'all, that was 2 minutes. Let's take a look at the answer.
For our standard free entropy, it's enthalpy, or change in enthalpy, minus temperature times change in entropy. So knowing this and looking back at part A and part B, we know that from part A, our change in enthalpy was negative 283 kilojoules, and our standard change in entropy from part B was negative 86.5 joules. But since we're dealing with kilojoules, we need to divide that by 1,000, which would get us 0.0865, and don't forget the negative, for our standard entropy change, and our temperature, which was given, and that is 298 Kelvin. And for the temperature in our standard free energy change, we always want to be in Kelvin. Now all we have to do is just plug in our numbers. So for our change in enthalpy, that would be negative 283, and we'd subtract the temperature, which is 298, times our change in entropy, which was negative 0.0865, and our answer for the standard free energy change would be negative 257.2. And remember, it said include units with your answer. So our units for our standard free energy would be kilojoules times 1 over moles. Or you could put moles to the negative first power. And that's your answer right there. Now let's look at question D, and it states, is the reaction spontaneous under standard conditions at 298 Kelvin? And we must justify our answer.
All right, 2 minutes. All right, y'all, let's take a look at what the answer is.
Well, before we do anything, let's ask ourselves, what does it mean for a reaction to be spontaneous? And you must know this. For a reaction to be spontaneous, the standard free energy change must be negative. Now, there are certain conditions in which the enthalpy could be positive or the entropy could be negative, this and that, with temperatures going up and down. But know that for a reaction to be spontaneous, if it can be spontaneous in any way, it must be negative. That standard free energy must be negative. Now, if we look back at part C, we can see that our standard free energy is negative. So yes, indeed, the reaction is spontaneous under standard conditions at 298 Kelvin. And here's our explanation. For a reaction to be spontaneous, the standard free energy change must be negative. And in part B, we found our standard free energy to be negative 257.2 kilojoules. So since this number is negative, it's obviously going to be spontaneous under the standard conditions at 298 Kelvin. Now we come upon.
All right, I believe this is the last part. Let me make sure. It is. This is the last part, so 2 minutes. All right, y'all, let's finish out this question.
On our final question of this entire FRQ, and it says to calculate the value of the equilibrium constant at Ke for the reaction at 298 Kelvin. Well, for this question, we're going to have to refer back to our AP Chemistry formula sheet. And usually with equilibrium constants, we'd have a specific concentration and set up that whole equation where you have like the products over the reactants. But in this instance, we're not given that sort of reaction, or we're not giving that sort of ice table type situation. So we have to refer back to our AP Chemistry formula sheet. And if you look at the thermochemistry / kinetics part of the formula sheet, you will see a formula in which the standard free energy change is found by something that looks like this, Q, and that R is our constant, T is temperature, and we get the ln of our equilibrium constant. So if we move the negative RT, we will get the standard free energy change over negative R and then temperature, which will equal the ln of the equilibrium constant. And that's how we can find our equilibrium constant. And we can plug in our numbers. We remember our delta G is 257 kilojoules, or 257.2 kilojoules. But for this instance, since our constant, this R is a constant, since that's in joules, we want to convert that 257.2 kilojoules into joules. And that was obviously negative, so that's going to be negative 257,200 joules, and that's over our R, which is our constant, and it should be given, which is 8.31 joules, and there's other units, but I'm just not going to write them. And for the temperature, since it's given, it's 298 Kelvin, and that'll equal ln of equilibrium constant. Now, if you solve this, you'll get 103.86 equals ln of the equilibrium constant, and the inverse of our ln of our natural log is going to be e to the power of x, so this is going to be e to the power of 103.86 equals our equilibrium constant, and once you put that in the calculator, your equilibrium constant will be 1.28 times 10 to the 45th power. That's your answer right there. I think the greatest thing you can get from this FRQ practice is to rely on your AP Chemistry formula sheet, because there are going to be some times where you might not be able to answer this question. Like, for example, E, I did have some trouble answering because I usually went the normal way of finding the concentrations of my products and reactants and having products over reactants, and that's how I'd find my equilibrium constant. But you have to look back at your AP Chemistry formula sheet. That's going to be your best friend throughout the entire exam.
All right, all right. How does everyone feel about that question? Now, people are saying this question is significantly easier than the previous. So yeah, and I think actually it's worth noting this question, I would argue, was not actually significantly harder than any other. It was just different. Tested different skills. I think a lot of people are stronger with thermo than they are with equilibrium. And so that's my view on it, at least. But we are going to take just a quick 5-minute break just to let you guys decompress, give you guys a minute to breathe. And yeah, we're here to chat for those 5 minutes. Let me actually start a timer here so we can stay on track. Phone, please work with me. There we go. All right. I know this night is going to be quite long. A lot of practice, a lot of problems. But y'all are doing great.
I believe we have 1, 2, 3 more after this one.
Yeah, which is actually, what was that then? A total of 5 questions?
Mm-hmm.
Okay, so that's almost an entire section. So y'all are getting some real AP practice here.
And obviously, on the College Board websites, they always post the FRQs from the previous years, and along with the scoring guidelines. So those are so good with the practice.
It's weird. I don't know what to
Guys,
talk about.
get up, take a walk. You've been sitting for a while. take a little break and come back.
Yeah, stretch your legs.
Get some
Within
water.
5 minutes. Eat something and come back. Okay, 5 minutes.
Nice job, Holly. We love that improvement. We got this, guys. You know, all day today, I thought it was Sunday. And I was like, oh my God, I have the Chem and AP Gov tomorrow. And then my dad was like, it's Saturday. I was like, oh.
I had the same thing today where I kept talking about like, oh, I've got work tomorrow. What if like you've work tomorrow? And I was like, oh, Saturday. I don't have work on Monday or on Sunday. It's been weird.
I don't know, it just feels like Sunday today.
I think maybe, I guess, no, most of y'all did not have a short week last week. I did. So, yeah, Massachusetts, we get off on April 17th.
Oh, wow.
Marathon Monday, baby.
Yeah.
I have a question. Have your school teachers been doing like AP review sessions for y'all?
Not really. We kind of spent the last few like weeks doing reviewing like anything that we missed, so like unit 9.
Like out
Yeah.
of school review sessions? Because I remember, well, not for AP Chem, but for AP Go, my teacher would like put like review sessions at 6:30 a.m. in school before school started, like for like the week before the exam. I like really hoped.
My chem teacher would do like Saturday reviews. So every Saturday, in like the 4 or 5 weeks after the exam, we would go in and we would just spend like an hour or two running through FRQs. It was actually pretty fun because it was just like my AP Chem class had like 9 total people. So we all kind of just hang out and like have fun doing chemistry. Which I know those are kind of ants, but
I know some schools do it on Saturdays. It's nice.
Yeah, my school would also do a lot of the AP classes would do like in-person mock exams where you would kind of get like an in-house field trip in order to like get out of class. My chem teacher hated when teachers did that though, because he was like, your class isn't more important than mine. And I was like, and I remember being really upset about it the first time because he wouldn't sign my permission slip to do some. But now that I'm here, I'm like, that's kind of valid.
Yeah. But I don't really, I like personally, I couldn't really be dependent on those review sessions. Like they were good, useful, but like I couldn't be dependent on them.
Oh yeah,
Also,
no,
College
they
Board
require
has their own review sessions, and I
Like, do they have
found
live
those.
review sessions?
Yeah, they had
Or they're
last year. I
recorded?
know they had like live review sessions like on YouTube, but I don't know about this year because I haven't been keeping up with their review sessions
I
this
thought they had
year.
recorded videos, but I didn't really see if they had them on YouTube. Like lives.
Sorry if you.
Personally, I don't like it when my teachers go out of order in the units for AP classes because like I like to know what unit I'm on while I'm studying. Like if
No,
they just go out of
literally,
order, it's on my nerves.
my gov class was all out of order, and I learned
Like, that would be
thermochem
my
before kinetics.
I mean,
I
I think
thought that was fine.
merging unit 6 and 9 makes sense. Well, actually,
I didn't do.
I just rather go on.
I did
I feel like
unit
if you
9 at the
merge-
very end of the year.
I feel like if you merge units 6 and 9, you lose a lot because you need that equilibrium stuff. Also, electrochem, I feel like that makes more sense. The idea of spontaneity, unless you want to teach it backwards, where you introduce equilibrium and then teach like spontaneity separate. I don't know. It's interesting. But that's, I think, the weird part of why unit 9 is like at the end, but units, I'd argue, do like equilibrium and acids and bases, and then do like thermochem and thermodynamics together at the end. That's my thought, at least. Anyway, that's 5 minutes and 30 seconds. So y'all get extra base time, break time. So let's get into the next question.
I'll go back up.
All right, let's see what this next question has in store for us. Oop, gotta Here we go.
Let's look at
And like before, I'll give you guys 2 minutes for each part.
this FRQ question. I'm not going to bore you with all the information up here. All we have to know is that this is an unbalanced chemical equation, and we're asked to identify the molecule or ion that's being oxidized in the reaction.
All right. So I'm actually going to give, yeah, I'll give 2 minutes for part A, 2 minutes for part B, 2 minutes for part C. That might be a little bit much actually for this question, but better to have more time than less in practice. All right, let's see part A.
Well, if you remember from past chemistry units, we know the acronym oil rig. And oil rig, the oil part stands for oxidation, is a loss in electrons, and the rig part is reduction, is a gain in electrons. So all we're looking for is which molecule or ion loses electrons, or essentially its charge becomes more positive. Let's start by tellurite. Now the oxidation number for oxygen is obviously going to be -2, and since our overall charge is neutral, we need to counterbalance that -2, which is obviously going to be -4 because 2 times 2 is -4. So our tellurium charge will be +4 because 4 minus 4 equals 0. Now let's look at our Cr2O7, and it has an overall charge of -2. Now we know that oxygen is always going to be -2 charge, so -2 times 14 is, or -2 times 7 is -14. So to counterbalance that and to make that equal -2, all we have to find is some number that will multiply by 2 and it'll subtract by 14 to get -2. And that would be +6, because 6 times 2 is 12, and 12 minus 14 is -2. Now our hydrogen oxidation number is obviously given, which is +1, and usually hydrogen will be +1. So as we can see over here, hydrogen is +1, oxygen is always going to be -2. So we have -8 on this side and 2, and our overall charge for this molecule is going to be 0. So we need to find some number that'll add to 2 and subtract to 8, which will be 0, and that would be +6, because 2 plus 6 is 8, and 8 minus 8 is 0. Now chromium charge is given, which is +3, and for H2O, hydrogen is +1, and oxygen is obviously -2. Those cancel out for overall charge that is neutral. So to identify the molecule or ion that's being oxidized, we can just look at these numbers, we can look at the oxidation numbers that we assigned, and see which one is basically becoming more positive. And if we look at our chemical equation, we know that tellurium is becoming positive, or the tellurite. So we can put that are molecule side, we could put TeO2 as the molecule that's being oxidized, or the tellurium ion that's being oxidized. Either of these answers would work. Now part B, we can answer that pretty easily because we
Actually, I'm going to keep us going for part B because it looks like, yeah, it's a pretty quick one.
already assigned all the oxidation numbers we needed to. And for chromium, the oxidation number in the chromium oxygen ion, or the molecule, was positive 6.
All right, y'all, let's take a look at 2 minutes for part C. All right, let's take a look at part C.
So now question C asks us to balance the chemical equation given above by writing the correct lowest whole number of coefficients on the dotted lines. Now since I don't have enough space over here, and you definitely have enough space, but since I wrote a little too big, I pulled the equation down so I could write it over here. And to start, let's look at what ions or what elements that we already have balanced. So let's look at tellurium, and over here we have one tellurium, but over here we have one tellurium. Now for oxygen in total, we have over here we have on the reactant side we have 9 oxygens, but on the product side we only have 5 oxygens. And for chromium we have 2 chromium. Over here we only have 1 chromium, and for hydrogen we only have 1 hydrogen, but on the product side we have 4 hydrogen. Now, with questions like these, you just want to experiment with which coefficients would work. So since we have the biggest discrepancy of oxygen, let's just increase the oxygen, the molecule over here to, let's put a coefficient of 3. So when we do that, we increase the hydrogen concentration, 6 over here, plus 2. So that would be 8 hydrogens on the product side. Tellurium would increase to 3, and oxygen would increase to 13. Now one of the other coefficients that we could put in front of the chromium is 2, because we have 2 chromium over here, so it's just easy to just put 2 chromium on the product side. So in total we have 2 chromium on both sides, so that'll balance out. We could just forget about this molecule right here. We could just put 1 because we're keeping that chromium, the chromium amount of chromium on the product, the reactant side and the product side the same. Now let's look at tellurite. And for tellurium, we have 1 tellurium on the reactant side and 3 tellurium on the product side. So it's just logical to put 3 over here. So we have 3 tellurium, we have 6 oxygen, and 6 plus 7 will get us 13. So we pretty much resolved our dilemma with the tellurium and the oxygen, so we can forget about that. And all we have to do is put an 8 in the hydrogen, since we have 8 hydrogens over here. So it just seems logical to just put an 8 coefficient on the hydrogen ions, and that's pretty much it. We have 3 tellurite, we have 1 Cr2O7, we have 8 of the hydrogen, and then that will be 3 over here, 2 for the chromium, and 1 for the H2O. Let's look at the second part of this FRQ. And it states in the procedure described above, 46 milliliters of a 0.03109 mole of K2CCr2O7 was added to ore sample after it was dissolved in acid, blah blah blah. The amount of unreacted excess Cr2O7 was determined by titrating the solution with a 0.11 moles of FeNO32, and the reaction that occurred in titration represented above right here in the balancing equation, and the volume of 9.85 milliliters of the 0.110 mole of FeNO32 was required to reach the equivalence point, and it's asked to calculate the number of moles of excess Cr2O7 that was titrated. So
All right, y'all, 2 minutes. All right, looks like we need some help on the balancing, so I can dive a little bit deeper into that. I'll go through it kind of still pretty quickly, but we will get through it. I'm just pulling up a whiteboard right now. Let's see. All right, let me sure. Can you all see the whiteboard? It's got a different problem on it right now, but there we go. Let's talk about a different question. Oh God, things are being all over the place. Give me 1 second, guys. I just gotta get the problem. All right, here we go. So we've got our problem. So I think it's worth remembering all balancing a chemical equation is balancing out the number of atoms on each side, right? Just the law of conservation of mass. All right. But remember that with the redox reaction, we also want to balance charge. So that's an important piece here. So, for example, we can see here the total charge without any coefficients. The charge on this side is -1. The charge on this side is +3. We've got an imbalance of charge. So let me just center this up real quick. So the first thing I'd like to do is just balance, make sure to balance. Typically, I'd use the half reaction method here, but this one, it's just a little weird. Sorry, I'm just looking at the scoring guidelines to make sure I use the right method here. Okay, so we know that we have, just to begin with, balancing out our mass, we have, how do I get rid of this? Okay, I'll write this down here so things don't get messed up. Okay, so we have 1 tellurium. We can count 2 plus 7 is 9 oxygen. We have 2 chromium and 1 hydrogen. And if I make any mistakes at this point, Anuva or Shreyas, anyone else watching, let me know because I'm doing this live, so I might make a mistake. And then we have, at the end, right, we react to form. We have 4, let me just go and see more. 1 tellurium. We have 5 oxygen. we have 1 chromium and 4 hydrogen. Actually, let me just double check that I actually wrote that out properly, but that's just the start. Okay. So we can see we have our oxygens unbalanced, our chromiums unbalanced, and our hydrogens are unbalanced. And odds are our telluriums are going to have to be balanced again as well, because when we modify one thing, it tends to fall apart. So let's see where we can start with this. I would say we can balance out our chromiums by putting a 2 right here to balance out the chromiums, right? So now the way it stands, we have 2 chromiums on both sides. Beautiful, right? That's the first step. Now let's look into balancing these oxygens, and that can get a little tricky, right? Because we have 5 oxygens here. So I would say what we want to do, sorry, I'm thinking through this real quick. Is I'd say we'd want, and some of these problems, honestly, you just kind of got to play around with the numbers until it works, which I know sounds very weird, but anyway, actually, let's balance out our hydrogens, right? That's easy. We can just try putting a 4 right here. We might have to change it, but let's just try it out. All right, put a 4 there, and we'll worry about charge in a minute. We can worry about charge in a minute. So now we've got 4 hydrogens and 4 hydrogens. Again, we might have to change that as we balance the oxygens. The oxygens are kind of the tricky part here, right? I would say we have 9 on this side, 5 on the other. So maybe if we do, this is tricky because especially with like odd numbers, you can't just like multiply things by 2. But if we add some oxygens over here, we know we can add oxygens in either 4s or 1s, right? Because we can't like change these numbers down here. We can just change these coefficients. So we can only on this side add 4 oxygens or 1 oxygen at a time. On the left, we can add 2 oxygens or 7 oxygens. So let's play around with this, right? If I have 3 tellurium oxides, that changes. So 3 tellurium, and now 6 plus 7 is 13 oxygen. We can now balance out that by saying we need to add 8 total oxygens. So we'll add 3 to here to get 12 plus 1, which is 13 oxygens. So now we balance our oxygen, but let's check if anything else just got thrown out of whack. Well, our tellurium's balanced, perfect. But our hydrogens are now all out of whack, right? We have 8 instead of 4. So we can just change this to an 8, and we've balanced out for mass. So it's a lot of guess and check. Balancing equations is a lot of guess and check. Next, let's just check our charge, right? It might work out, it might not. With an equation like this, it's actually kind of tricky to do a half reaction because I think you have 3 half reactions or a bunch of half reactions. It's weird. Not really half reactions, but the total charge on this side is -2. Let me actually use text. It's hard to write. -2 plus 8 plus, right? Because we have 8 H plus and 1 minus 2. And on this side, we have +6, right? So we can see that our charges are balanced because -2 plus 8 is 6. So that's how we would balance this equation. It's a tricky problem. And yeah, anything that I haven't written a coefficient for, assume it's a coefficient of 1. Yeah. So let me actually pull up. I'm going to pull up the actual scoring guidelines real quick. So we can take a look at them together to see what actually this question would have wanted us to do. So 1 point is earned for either 2 correct balances among CRH and O charge and tellurium versus, so it looks like they wanted us to balance the charges, and we did it by balancing by inspection, right? We balanced by inspection to balance charge, and then another point for just a correctly balanced equation. So it's, again, a tricky question, but typically with most of these, it's trial and error. Yeah, this was a tricky redox reaction, but let's move on to, I think personally, my favorite part of this question, because I love a good redox titration, and that is the redox titration. So let's take a look.
Of K2CCr2O7 was added to ore sample after it was dissolved in acid, blah blah blah. The amount of unreacted excess Cr2O7 was determined by titrating the solution with a 0.11 moles of FeNO32 in the reaction that occurred in the titration represented above, right here in the balanced equation, and the volume of 9.85 milliliters of the 0.110 mole of FeNO32 was required to reach the equivalence point, and it's asked to calculate the number of moles of excess Cr2O7 that was titrated. So all we have to really know for this question is the titration part, and it's at FeNO32. Now over here on the balance equation, you might be wondering where the NO3 went, where that nitrate went. Well, since this is a titration problem, when we're creating our balance equation, we want to have a net ionic equation. So we want to take out the spectre ions. And in this case, the nitrate was a spectator ion. This is why it's not binding to the iron, and iron is just alone as an ion. Now this seems like a basic stoichiometry question because we're using the amount of titration from the iron and the nitrate.
Do we want to pause it for this one? Okay. I thought just because we worked through the other one. Okay. I'll give you guys 2 minutes for part A. Sorry about that. You got a little extra content, but sure, we'll start with part D. So 2 minutes. All right, that was 2 minutes. Let's see what Jahanger has to say.
Titrate, and we're calculating the number of moles of excess of the Cr2O7 that was titrated. So all we have to do is go from the iron all the way to the Cr2O7. And the way we do that is through basic stoichiometry. And since we have six irons equals 1 mole of Cr2O7, we can assume that our number of moles of excess Cr2O7 -2 moles would be equal to 1/6 of the iron. Now, since we got the stoichiometry mole ratio, we can use the iron 3 nitrate, the information that was given, in order to find the Cr2O7, because this is the same amount of resources that's used for iron 3 nitrate to produce our Cr2O7. So that would be, since we have 1/6, that would be 1/6 of Fe2 plus, and we have it being in 9.58 milliliters of 0.110 moles of our iron 3 nitrate. So that would basically be 1/6 times 0.00985, and then we multiply that by 0.110, and that would get us 0.000181 moles. Now, some of you may be wondering why we multiplied the liters by the molarity, and it's because M equals N over L. So we multiply L over, and then we get L times M equals the moles. And since we got 1/6 as our moles, we need to multiply that 1/6 by the moles of iron, or the iron 3 nitrate, but since we took out the nitrate, it would just be iron. So we're multiplying that 1/6 by the amount of nitrate, the amount of iron 3 nitrate that we have, in order to get the moles of Cr2O7 and has a -2 charge. This is just basic conversion, going from the iron all the way to the Cr2O7. We're using the same amount of resources, but we have to account for the mole ratio, and that's all. Now let's look at question E. And question E states to calculate the number of moles of Cr2O7 that reacted with the tellurite. Well, if you remember from our past equation,
All right, y'all. 2 minutes for part E. It's part E. All right, let's take a look at the answer.
we know that the molecule that reacted with tellurite is K2Cr2O7. Now, the potassium wasn't shown, and because the potassium was a spectator ion, it was taken out. So, it says in procedure described above, we have this amount of K2Cr2O7. We have 46 milliliters of a 0.03109 moles of that. So all we have to do is subtract the moles of Cr2O7 with -2 charge. That is added, and we subtract that by the excess moles of Cr2O7 to -2 charge that was titrated. Now, the moles that were added were given above, so it's basically 0.046 times 0.03109, and obviously we put 0.046 because this is liters, and we're given milliliters, so we need to convert that. Divide 46 by 1000, you get 0.046, and we want to subtract that by our answer from part D, because this is the answer that we found from calculating the number of moles in excess of the Cr2O7 that was titrated. So that would be 0.000181, and when you multiply 0.046 times 0.03109, and you subtract that by 0.0000181, 0.81, you get 0.001249 moles of our CR207, and that's your answer. Now my handwriting is
All right, so it seems we want a little bit more details on this one. So let me pull up the whiteboard. Give me a quick second to get set up here. Think y'all can see the whiteboard? Perfect. All right, let's get this party started. I have to just grab a screenshot of the question so that we can actually do it. Let me just move down here. Okay, I just screenshotted it from the video. So, all right. So we are asked to. So we are told. Okay. So we are asked to calculate how many moles of dichromate, that's that ion, that reacted with tellurite, right? So we know that some amount of moles of dichromate reacted with tellurite. Tellurite is TeO2, right? And we know that from the reaction above. Let me grab it up here. There we go. All right, so here's our reaction, right? This is what is happening when tellurite reacts with dichromate, right? That we have established this reaction. I'm actually going to work through this first by just explaining how did we get here, right? Because there are a couple of different steps happening, and it's a little weird. So we have that reaction happening, right? Tellurite reacting with dichromate in acidic solution to form hydrogen tellurite some ion, I don't know what that is, Cr3 plus, and a water because of the acidic part, right? So in the procedure described above, right, that much potassium dichromate was added to the ore sample after it was dissolved in acid. So we've taken this reaction, right? We did it, and then we added some potassium dichromate. Next, we determined how much excess CrO2 was present by titrating. So we basically wanted to figure out how much CR207 2 minus was still left in the solution, right? And that's why we did that titration, to find out our concentration. So we first figured out how many moles of excess dichromate was titrated into the solution. And we found that to be 0.00018 moles in the last problem. And that was the exact same problem as any sort of equivalence point problem. Just basically, we have some amount of dichromate in here, right? How much do we have? And we found it to be that. So we want to figure out how much actually reacted. Well, we know that every bit of dichromate was added, and some of it reacted, and some of it was excess, right? We know that, right? It either reacted or became excess. So we know that actually the total added, let's work through this backwards. The total added, and it's actually total dichromate added, is equal to, well, how much reacted plus how much was excess, right? All of it either reacted or was excess. We know that, right? That's pretty simple. So now if we rearrange this equation, we can find that the total reacted, what we're looking for, is equal to total added minus total excess. Everyone follow me so far? Let me just make sure in the chat things are moving. We understand how we got to that equation of total reacted equals total added minus total excess. Awesome. So let's keep moving forwards, right? Let's do our math. Well, how much tellurium, how much dichromate was actually added? Well, we see it right there. We added 46 milliliters of 0.3109 molar potassium, that's a spectator ion, we can ignore it, dichromate. Beautiful, right? So we can figure out how many moles that is in just a second, but I find it useful sometimes to just literally write out the exact information that we have. The total excess, well, we found that before, 0.000181 moles. Beautiful, right? So next step is to find out, well, how many moles is this? So let's do the dimensional analysis. 46 milliliters times 1 liter per 1,000 milliliters times 0.3109 moles per liter. And then subtract that from 0.000181. Do we all understand how we got here? Let's just another quick check of, do we understand how we got these numbers? Just drop like a yep, feeling good, something like that in the chat. Just let me know we're good to move on. Awesome. So next step is just to do the math, right? This is literally plug it into your calculator. 46 times 1 over 1,000 times 0.03109 minus 0.000181. Plug that into a calculator. We get a number that I hope is right. Yes, it is. Whew. Thank goodness. Right, and our final answer is that many moles reacted. And it's moles of, technically it's moles of potassium dichromate, but again, we don't care about potassium because it's just a spectator. Sorry, potassium, but you know, we'll hang out with you another time. So that's what we got our answer. And the 0.3109 or 0.3109 or whatever it is, it came right here. It was written in the problem. We're told how much dichromate was added after the reaction took place. Right, so basically, we know that we have we're told that this reaction takes place, right? Which looks to be actually no, they're different. We're told we have some amount of dichromate in this solution, right? And we used iron nitrate to figure out the concentration. That's how we figured out how many moles of excess were present, because everything else that reacted with the tellurium oxide, right, became H2TO4 and chromium ions, right? It didn't stay as dichromate. So we added iron nitrate to eat up the excess, right, until we had no more dichromate left. And then from there, we could figure out how much reacted, because we knew how much dichromate we added to have this reaction happen. Therefore, we knew how much we could calculate the excess, and from there we could calculate the total. It's a lot of stoichiometry. It is just a lot of stoichiometry. That's all these problems are, right? That's basically the idea. We did this reaction, and then we wanted to figure out how much excess there was, and then we wanted to figure out how much actually reacted. So there we go. Let's move on to the next part, which asks us to find the mass of tellurite that was in the ore sample. And I just realized I have to share my screen again. Uh-oh. There we go. Should be up now. So I'll give you guys 2 minutes to work on this problem. All right, let's take a look at the answer.
Pretty bad, so it might be hard for you to understand the thought process that went into this, but it literally asks us to calculate the number of moles that reacted with Tellurite, and we're given this amount of moles that was added. So that's the amount of moles, the 0.046 times this number, that's the amount of moles that was added, and the excess is that what we found from part D. So you always want to get your total, what you had before, minus your excess in order to get the amount of moles that reacted with the Tellurite, the moles that actually was in the reaction, that actually reacted. Now our last question asks us to calculate the mass in grams of Tellurite that was in the ore sample. Well, all we have to do is that since we already found part E, which is calculate the number of moles that reacted with Tellurite, we can get that number, which is 0.001249, and that is the moles of Cr2O7 to the -2 power. And all we have to do is multiply that by, since we have 1 mole of Cr2O7 -2, we're trying to convert it to Tellurite, and from part A, when we did the balance equation, we learned that it was 3 moles of Tellurite, so 3 moles of TeO2, and to convert that into grams, we have to multiply by the molar mass, which was 156 or 159.6 grams of Tellurite. And you can find that from your periodic table, looking at the molar masses of each of the elements and adding them up. And that'll be for 1 mole of Tellurite. Moles would cancel out. So we would get grams. So this is just this number times 2 times the molar mass. And your answer would be 0.5980 grams for the Tellurite that was in the ore sample. So this is one of our longer FRQs, and as you can see, each part matters. The answer you get from part A really affects the answer you get from part F, and the answer you get from part D really affects the answer you get in part E. So all of these are like dominoes. If you mess one of the problems up, if you messed like problem 8 up, you didn't get the right answer, this could cause a cascade of just incorrect answers. So that's kind of the thing about long FRQs, is that each question matters. You need to remember that each question matters.
All right, so I think because you guys were asking for it, we are going to do a lab-based FRQ. All right, so we've pulled one up. We're going to do it live for you guys. Actually, let me take a look at what the next question is, just so I know. Yeah, all right, we'll do the lab-based FRQ. I think that was the. Oh no, there were like a handful left. Okay, so we'll see where we get to, and then. But let's start by working on a lab-based question, and we're doing it live. So please give us your patience while we're working through the problem. Let me just get us all set up here. Give me one moment. All right, so we're going to be working through problem number 3 for this one. So let me just pull up the question, get everything set up, and then we can get started.
Yeah, it is also up to part G.
Oh, this was a long one. Oh, this one's
a really long one.
Ooh, I see a nice little graph. Okay.
There's a graph, there's the whole experiment, write a procedure, all of that. So we're going to have fun.
I suggested we do a precipitation titration problem or redox titration, but Anuva shut me down. So anyway, let me pull up the whiteboard here. Whiteboard. Okay, so let's take a look at this first question. All right. Let's see. It's still uploading. Give it a second. Whatever. We'll just move on. There we go. A student is given the task of determining the molar concentration of a copper sulfate solution using copper 2 sulfate, actually. Sorry, I'm a stickler for naming. Using 2 different procedures, precipitation and spectrophotometry. Right. So we're going to be talking about 2 different lab procedures in order to find a precipitation. Actually, technically, I think this precipitation would be done using titration. But anyway, that's the lab procedure. I love titration. Anyway, for the precipitation experiment, the student adds 20 milliliters of 0.2 molar barium nitrate to 50 milliliters of the copper 2 sulfate. The reaction goes to completion and a white precipitate forms. The student filters the precipitate and dries it overnight. The data is given in the following table: the mass of the dry filter paper, the volume of copper 2 sulfate, the volume of 0.2 molar barium nitrate, and the mass of the filter paper with the dried precipitate. First part asks us to write a balanced net ionic for the precipitation reaction. So actually, we don't even need this data yet. For part A, we know that we have two species reacting, right? And we'll balance it next. So we have copper 2 sulfate reacting with barium nitrate. Actually, we'll do barium 2 nitrate anyway. So this is going to react to form copper nitrate, copper 2 nitrate, and barium sulfate. Let me make sure that's correct, right? And we'll balance out what's actually, is that balanced? Is that balanced, or am I just dumb?
I believe so.
Okay, but that is not a net ionic, but it looks balanced.
No.
So now let's write out our full ionic equation. So we know that we have, well, let's also add states to make this more clear. We have, both of these are aqueous.
Oh, Dylan, people are asking if we could just pause it and then let them work it out for like 2 minutes.
Oh, sorry.
Maybe.
Yeah. Sorry, got too eager there. Well, I gave you a little bit of extra answer, but finally net ionic.
Not the full answer.
Yeah. All right. We'll give you 2 minutes.
Oh, here.
Is it not balanced?
It looks balanced.
I was going to say, nothing was actually moved around. Or it was just things moved around. Anyway, find the net ionic.
It's number 3, by the way, in that link I just posted. And we recommend you write the states because it just makes it a lot easier to keep track. But I believe they won't, at least for this part, they won't take off points. Guys, don't do that.
Wait, what were people talking about doing? Oh, no. The joke every AP student makes.
Can someone repost the question?
It's question 3. We're working through part A.
Oh, no, I meant like what Faith was asking. Ruth's previous question.
Oh, sorry.
No, you're good.
What was Ruth's question?
I don't know.
One quick question for FRQ tips. In calc, we were told if we don't know the answer for part A and we need for part E, to just use a random number and continue, and we wouldn't lose the same point twice. I believe there are consistency points. So if you like don't have an answer for part A and then you write just like a dummy answer, but I bargain. That's tricky because it's like with calc and chem, if you need the answer and then you like find the answer later and then come back, you have to redo the whole problem. So it's maybe if you know you'll have the time to come back and redo both of those parts, then sure. It really depends. But I'd say try everything. And if you really can't even get a number out of anything, then sure. But like do your best not to have, that should be like a last resort. But anyway, that seems to be the 2-minute mark. So let's take a look at how we can find this net ionic. So we know how this reaction will occur because we know, well, because it's a double replacement, because we know, honestly, it's kind of just something I memorized of how precipitation reactions work. But we know it's going to be a double replacement because we have 2 molecular species that are breaking up, and we know that basically, we know that the negative part of one ionic compound will go with the positive part of the other. So barium will go to sulfate, and copper will go to nitrate. So the second part is, how did we know that barium sulfate was actually the solid here? Well, we know, the way I thought about it was, I know most nitrates are soluble, and so we said this was aqueous, and that barium sulfate was the solid. Now let's try to find the total ionic equation. Well, when aqueous, we have copper 2+, we have SO4 2-, we have barium 2 plus, we have 2NO3 2 minus. Actually, I'm going to write these charges in parentheses just to distract from any sort of like, just for the sake of typing. And we know this reacts to form copper 2 plus, once again, 2 nitrate, again, because this is aqueous, so it's break up. But now look at barium sulfate. Well, we know that it doesn't break up because it's solid. So canceling out anything that's the same on both sides, we find a net ionic of barium 2 plus reacting with sulfate 2 minus to form barium sulfate solid. That will be our net ionic equation. So does everyone understand how we got there, or do we want to go over that again quickly? Well,
And-
up to the chat. I'm just going to also.
And they also they literally tell you what the what do you call it? Like the products and the reactants are. If you look at the question, it says what is reacting, and then if you look at the chart, it will say the copper sulfate is aqueous and the barium nitrate is solid. Also, I know I said sulfates aren't soluble, but I think
Yeah,
I
the
might be
sulfate's
wrong.
insoluble. The sulfate is insoluble.
Oh, okay.
Or at least it's insoluble enough to form an actual precipitate, so its molar solubility is significantly low.
Yeah, okay.
Okay, next question. Calculate the number of moles of precipitate formed. Well, first we need to know how much precipitate was actually formed, right? So, well, we know that we have 1.136 grams of filter plus precipitate. And we know we have 0.764 grams of filter. So we know that the precipitate is equal to 1.136 minus 0.764 grams, right? Just basically filter plus precipitate minus filter, which gives us a total mass, I said grammage, of 0.372 grams of barium sulfate.
Dylan, they're asking to work.
Oh, I'm sorry. I keep
It's
forgetting to
okay.
do that. This was a simple
It's okay.
problem. Actually, it's not done either. I'm sorry. I keep doing that.
No, it's okay.
I'm bad at that. I apologize. Yeah, I'll give you guys another minute to find how many moles that is. I'm sorry. I jump right into the explanation. I'm so sorry. It's because to me, I'm also doing this problem. And
Mhm.
so I'm like, okay, let's just jump right into it. If I do that again, if you hear me start the problem, please cut me off and be like, stop.
No, I didn't even realize until someone said it in the chat.
I know. I'm sorry, y'all. It's fine. Everything's fine. I just find chemistry so darn fun. So this would be more fun if it was a titration. No, I'm kidding. Yeah, actually, so let me move this over. I'm just gonna move the problem actually, because now y'all can't see my work, and zoom in on the table. So y'all can have a bit more room to work.
Yeah. Also, I believe that sulfates are not soluble when they react with group 2.
Yes, like barium. Also, let me just drop a link to the problem again. Original problem, we're on part B of number 3. Oop, Ruth almost beat me to it. All right, so that was a minute gone. I apologize for jumping the gun, but we can then just convert this to moles. So first, let's find the molar mass of barium sulfate, which is the molar mass of barium plus the molar mass of sulfur plus 4 times the molar mass of oxygen. So using a periodic table, which I have to pull up, molar mass of barium is, where's barium? It's all the way down there, 137.33, plus the molar mass of sulfur, which is 32.06, plus 4 times the molar mass of oxygen, which is like 16.01 or something.
Yeah.
15.999.
Same thing.
I'm using p-table. Use whatever numbers are on the periodic table on your exam. just because those are the specific ones they want you using, which they shouldn't be far off from these. But I think I've seen like 16.001 or 15.999 for oxygen. Yeah. All right. So that gets us an answer of 233.38 grams per mole of barium sulfate. So now we can just do the unit conversion. So 0.372 grams times 1 mole per 233.38 grams, which gets us a total number of moles of 0.00159 moles of barium sulfate. Okay. Gone through the first two parts. Now let's look at part C. And I will let you guys do it on your own this time. I won't forget. Okay. Calculate the molarity of the original copper sulfate solution. And yeah, I'm looking at the answer key right now. Yeah, so it asks for the correct calculated value consistent with part B. So if you had messed up on part B, you would still get a consistency point for part C if you did it right.
Yeah, and this is a 2021 exam, so I remember taking this exam.
Oh, is this the exam you took? Like you did this one in real time?
Yeah, I tried to self-study this one, and then I was like, I ended up just still taking it, even though I like gave up, because I was like, this is just too much to self-study.
That's fair.
But I remember, yeah.
I can't imagine self-studying this exam. That's too much.
No, I realized like I started self-studying in like September, and then like by like February, I was kind of like, this is not happening. The answer for part B was here, I'll put it in the chat.
It was like 0.00159 moles, right?
Yeah.
Yeah. If you, after we go over the problem and after you've given it a fair try, you can find the answers online. So if you want to like look at the work, it's there. Also, I'd like to note, actually, I'll explain this when we go over the problem. There's just a little stoichiometry note here. That's kind of fun.
Yeah, I think College Board, like they put the scoring guidelines and like the FRQs like 3 days after the exam. And I remember like last year I was like waiting for them to post it so I could see how many points I got on my FRQ.
Yeah, usually it's the questions are released 3 days and then the answers don't come out till like August.
Oh, really? Okay.
Yeah, it's like after the readings and stuff.
Oh, I know like 3 days after, like it's always like people on YouTube like answering all of them.
That's
then,
what it
like,
is.
Yeah.
Oh, those are always so fun to look through. On my AP exam, I accidentally did a question right, but in the wrong way. And so I was like freaking out about whether or not I did it. It was great. Once I saw that and then I found out that I actually did get the right answer, but with the wrong method. It was awesome. Okay, so let's calculate the molarity of the original solution. So we know that molarity of that solution is the moles of copper sulfate present divided by, well, we had 50 milliliters, so 0.050 liters. Right, and that was just a quick division by 1,000. So, well, how many moles of CuSO4 do we have? And I want to know, as I'm going through this, don't just note the work I'm doing, but also the process which I take. So if you had just jumped into this and been like, I need every number possible, you might be a little bit crazed. What's important is to kind of think like, what do I actually need to find, and then work kind of backwards from there. So how many moles of copper sulfate did we have? Well, we knew we had a total of 0.00159 moles of barium sulfate, right? And that was what was reacted. That was the product of our reaction. And I want to note, we're told the reaction goes to completion, meaning there's no excess, right? When the reaction goes to completion, to my knowledge, if it doesn't explicitly state there was an excess, we can assume that we had stoichiometrically equal quantities. So we know that to form the barium sulfate, if we look back at the reaction here, we had 1 mole of copper sulfate for every 1 mole of barium sulfate produced, right? That's just stoichiometry. There, we can multiply, that's just 1. We had 0.00159 moles of copper sulfate present in the solution. Therefore, molarity is 0.00159 moles per 0.05 liter, which gets us a molarity of, there it is, 0.0318 moles per liter. Also, let's not talk about leaking the exam, please. That's not allowed.
Guys, the exam's not going to be leaked.
It's not. People want to, but it's not. Also, typically, if you're taking an early exam, it's not the same exam that the others are going to get. So actually, it won't be. It absolutely won't be.
Yeah, they have like multiple forms for a reason.
Yeah. So that's part C.
Also, like if you carry your decimals over, like you do like the entire like trail of decimals, like you'll still get correct answers. Even if it's like by like 0.001 off. As long as you're doing the right work, they'll like the teacher grading it will see it.
Yeah. All right. So let's look at part D. And we're moving into a different part of the question now. All right. For the spectrophotometry experiment, the student first makes a standard curve. The student uses a 0.1 molar, 0.1000 molar solution of copper sulfate to make 3 more solutions of known concentrations, a 0.05 molar, 0.03 molar, and 0.01 molar in 50 milliliter volumetric flasks. Calculate the volume of 1 molar, 0.1 molar copper sulfate needed to make 50 milliliters of 0.05 molar copper sulfate. All right, so I'll give you guys 2 minutes. This problem sounds scary, but it's actually not as bad as some may think.
Yeah, me and Jahangir are both taking it on Monday. So we're in it with you guys. And I believe in like every AP Chem test, Dylan, you can correct me if I'm wrong, but there's like always at least one question that's like really long.
Yeah, I mean, there's typically, what is it, like 3 long questions, 4 short. And the long questions usually go to like they're usually like 6 or 7 parts. The short ones are usually like 4. The short questions are also, from what I've noticed, the long questions typically are more like narrative based, where it's like they feel like they're like continuous throughout, where it's like you do a problem and then there's a problem based on it. The short ones are usually very much like computation heavy. Like these long questions are where they'll ask you your big conceptual like lab questions. The short ones,
yeah.
it's stuff like, we have this gas, find the pressure in the container given volume and like moles, and use PV equals nRT. Or like, I know on my exam, one of my problems for the short one was like a PES spectrum. There were like 3 questions about it. They're pretty chill, and they can kind of be fun. All right, so that's 2 minutes. Let's talk through part D. Part D might sound scary, but it is just a dilution problem, right? We're told we know we're going to be using M1V1 equals M2V2 because we're forming a solution with a certain molarity. So we know that the molarity is 0.1 molar. We got the volume. Molarity second is 5 molar of 50 milliliters. From there, we can solve for V1, and that will get us 25 milliliters. That's actually really all there is to this problem. You can convert this to 0.050 liters, and this will get you an answer of 0.025 liters, I guess, which is equal to 25 milliliters. That's all this problem is. So yeah, we're just talking about actually forming a solution. Anytime they're asking you like, how do you make a solution with this given solution, you're typically just going to have to find some sort of dilution. All right, so part E of, I'll warn you now, there are a total of G parts. So we have E, F, and G. But E is a problem that I think a lot of you guys have been asking about. So we finally built up to it. And that is
Procedure.
the procedure. I can hear you guys just cheering from here. So I have to sign up for this. Give me a second. It's going to make me do something so I can save this board. Ugh.
Okay,
But yeah,
so while
2
Phil's
minutes.
doing that, for part E, briefly describe the procedure the student should follow to make 50 milliliters of a 0.05 molarity copper sulfate aqueous using 0.1 molarity of copper sulfate. 50 milliliter.
Oh, sorry, it's restarting.
Okay, a 50 milliliter volumetric flask and other standard laboratory equipment. Assume that all appropriate safety precautions will be taken.
That'd be pretty funny if they didn't ask you to specify and you were like, well, the student's going to burn their arm down. All right. So yeah, I'll give you 2 minutes for this one.
I think this would be considered more of like a dilution.
Yeah. This is actually a tough question because, like, if you haven't done this and haven't learned like how to properly do this in a lab, it might feel really weird where you're like, well, just pour it all in a thing. But there is actually a proper way to create a diluted solution that maybe you'll learn it tonight. I actually didn't know this before reading this question. So if I'd gotten this on the exam, I probably would have gotten it wrong.
I don't know if there's one of these in every single exam, but I've seen it in a lot of them.
They're all over the place. They might not ask you to design a procedure, but they might ask you about a lab procedure. Like, for example, they asked me my year, about a redox titration where I had to read a burette. You have to know how to read a burette. They've asked me about, I've seen questions about like where they'll ask why a certain lab procedure might give a certain result. Like, for example, drying, under a drying vent might lead to this, and precipitation might lead to this, X, Y, Z. Listen, redox titrations are cool, all right? Listen, they're cool. They're fun. And yeah, the first part of that question was just read the burette. I got that free point. And then I proceeded to get the entire rest of the question wrong. But anyway, so part E, design a procedure that the student should follow to make 50 milliliters copper sulfate, 0.05 molar copper sulfate using that solution, a 50 milliliter volumetric flask, and other standard laboratory equipment. So all that means is like anything you would typically find in like your high school lab, or your college level lab, you can probably use it, but don't be pulling out like particle colliders. So we have 2 steps here. Oh, this is tiny. There we go. So we have 2 main parts. Right. First, we need to measure the volume. Oopsies, there we go. And 2 is to dilute the solution. Right. Those are our 2 parts. So for 1, measure how much? What was the volume? It was 25 milliliters? Yes. So measure 25 milliliters of 0.1000 molar, because that's what we have. Was it copper sulfate? Yeah, copper sulfate.
Yeah, copper sulfate.
Thank you. Right. Using, for example, I would use a graduated cylinder. You could also use a burette. Up to you. I think the scoring guidelines explicitly say a volumetric pipette, a graduated cylinder, a burette, any of those are acceptable. So we've measured out the correct volume. Now the second is to dilute it. So transfer the 25 milliliters into the 50 milliliter volumetric flask. And dilute with water up to the 50 milliliter mark. That's the whole problem. Right? First, we need to find our 25 milliliters of copper sulfate. We have to measure that out, put that, and then add the 25 milliliters of water to make it a 50 milliliter solution. That is our entire answer right there. Might seem scary. It's just 2 steps.
Yeah, it's not as hard as some people might think.
There we go. All right, so let's take a look at part F. We've got a chart here. So all y'all who are talking about wanting lab questions and graphical analysis, this is the question for you, man.
We did use a pipette. We mentioned that, a volumetric pipette.
Yeah, the three correct answers for the first step would either use a volumetric pipette, a graduated cylinder, or a burette. Any of those were acceptable. And generally, I'd assume any sort of like specific measuring equipment for measuring precise volumes would be fine. But like those 3 are kind of the like, that's what those are. I mean, stirring the mixture might be like a step, but really what they wanted to see was that you were properly able to just like form the solution. And then stirring is like, dissolving. Yeah, it was only 2 steps. All right. So the absorbance of the copper solution of unknown concentration was 0.219. Determine the molarity of the solution.
For part F, you have to take a look at the graph. For sig figs, I would use the sig figs that are given within the X and Y axis.
Yeah, correct me if I'm wrong, but when you're like reading a graph, isn't it typically you use the number of like known figures plus 1 uncertainty figure?
Yeah.
So like, for example, it would be like 0.04006 or something. I think. Honestly, don't think too hard about it and use 3 sig figs. That's my general rule of thumb, because typically you'll be right.
Guys, if you request to join the stage, we're going to deny it.
We'll just say no. Yeah, it sends us a little notification that's like, XYZ would like to join. So I'm gonna ask a good question. Should we use the Beer-Lambert law? Right? You could, if we had the cell length and the A equals ABC, if we had the cell length and the total absorbance. So we don't know the cell length, and that's the problem of why we can't use A equals ABC. And the cell length is like the length of the thing that goes in the spectrophotometer. So that, and obviously that can change the absorbance. So you have to know that as part of the equation.
Yeah,
All right.
the graph is literally given to you, so you like don't need to use the equation.
Yeah, you got to use a graph. There are 2 solutions, and I'll show them both. One of them, literally like the scoring guidelines, one of them is like a math thing. The other is literally just estimated value from the graph. Like, it's like that's the whole answer.
The graph.
So we're told that the absorbance equals 0.219. So 0.219 is like right there. Move over to the graph. All right, that's like 0.035. And there's your answer. I will note, you do have an acceptable range here. The acceptable range is anything between 0.032 and 0.038. So if you got any answer like that, like if you said 0.034 or 0.037, also valid. Now let's look at actually how we might like do this mathematically to feel a little bit more safe in it, because we kind of did that very quickly. So let's find the equation of this line, this like regression right here. Well, we have 2 points, 0, 0, and what is that, like 0.1 and like 0.6, like 3-ish, let's say, right there on that line. So now we can just say, well, y equals, well, we went up 0.63 and over 0.1. That's our slope. Perfect. We know that our y is equal to 0.219 molar. Or excuse me, not 219 molar. Sorry, just 0.219. Right, that's the absorbance we were given. Yeah, 219 is equal to 0.63 over 0.1 x, which implies that x equals 0.219 times 0.1 over 0.63, which gives us 0.035. Same exact answer as before. It's just this one uses, it's actually 0.0347, but same process. Honestly, this is overkill. This second part is like, if you really wanted to be sure, they want you to just look at this graph. That's all they want from you.
Sorry, I realized that like, so you can either use this equation or like estimate through the graph, like use the equation that y equals mx plus b. But
that's exactly
I
what we did here,
genuinely
yeah.
don't think it's possible to use Beer-Lambert's law.
It isn't at all.
Yeah.
Because the Beer-Lambert law is based on the fact that we have like, oh, this is gonna be so fun to type. We have like light headed towards this cell, and then we have a certain frequency of light coming out. And what we need to know is 3 things. Well, we have, so A equals ABC, A equals absorbance, B equals cell, A right here equals, it's like the molar absorptivity constant.
Yeah, something like that.
B is the cell length, C is concentration. You don't have either of these, so we can't use the Beer-Lambert's law. But this was actually also the first thing that came to my mind. When I saw spectrophotometry, I'm like, oh, we're going to be using Beer-Lambert's law. Guess not. But it's always something to keep in mind, right? Like, think about it. Even if you guys aren't, even if it isn't the right thing to do, you're thinking the right direction. All right. The final question of this, final part of this question. It's a doozy. So G, a second student performs the same experiment. Oh, also, I want to make the note because you might not know this. The actual like thing put in the spectrophotometer, and this is useful to know, is called a cuvette. That's what that is. Like this, this right here, like that's the cuvette. So that's the idea. All right. So the second student performs the same experiment. There are a few drops of water in the cuvette before the second student adds the copper sulfate solution of unknown concentration. Oh no. Will this result in a copper sulfate solute concentration for the unknown that is greater than, less than, or equal to the concentration determined in part F? So first we need an answer of greater than, less than, or equal, and then we need a justification. All right, 2 minutes.
Points are not taken off for misspelling as long as they can figure out what you were saying. Yeah.
Also, I think there was a like an acceptable range for that question. Let me drop the acceptable range. Yeah, the acceptable range is between 0.032 and 0.038. So if you said like 0.04, that would be considered incorrect. Wait, PJ, I mean, the K and the K, it depends on the context.
Yeah.
Like the equation. Can you give an example? Like K to me, capital K could either mean the equilibrium constant. It could mean K's kinetics, K's equilibrium.
Well, you'll always like have context to it.
I was gonna say it's context dependent. But yeah, on the spelling note, as long as they can tell like what you're talking about, like, oh, I'm talking about, if you spell, yeah, like Holly said, if you write trigonal pyramidal and you spell like pyramidal with an E, they're not gonna take it off. But yeah, if you spell trigonal pyramidal and somehow miswrite it like so poorly that they're like, I have no idea what this guy's saying, you'll lose points. But it's pretty hard to do that. Like, it's really hard. This is a STEM exam, not a writing exam. Honestly, I don't like problems that make you like estimate from a graph, just because you'll always have those edge cases that it's like you put 0.031 and it's like, well, you definitely did it right. It's just, yeah. And then after this, what do we want to do for the remaining 10 minutes? Because I don't know if that's enough time to go through a whole FRQ. Do we want to just like chat about chemistry?
Yeah, sure.
Sounds
And then
good.
tomorrow, I think I won't be here tomorrow. I know, kind of sad. But tomorrow, you guys probably should go through like an E-cell FRQ.
Yeah, that's the goal. We'll be doing like an hour and a half, 2 hours of total practice. So you're gonna get tons of practice tomorrow on all the things you don't feel confident on.
Yeah, I'm not here tomorrow
That
either.
time, I will be here. I'm kind of running the show tomorrow. It's gonna be fun. All right. So let's talk about whether it's less than or greater than or equal to. Typically, honestly, in these problems, equal to is the less likely solution answer. Doesn't mean it's not possible, but like usually they're asking you about something that's changed and like that changed thing. So anyway, so part G. This will result in a concentration less than part F. Right? And actually, usually if you have an answer, you're usually like less than because something, right? So what's our actual answer? Well, the additional water will decrease the concentration in the cuvette, right? That's just simple. A higher volume of water means a higher volume with the same moles. Molarity is different. So the water will decrease the concentration in the cuvette, right? Therefore, absorbance will be lower, resulting in a lower estimated concentration. And before that, they were asking for the estimated concentration, not the actual concentration. So I believe just this is like part of the answer, but not all of it, because you need to state that because the concentration is lower, the absorbance will be lower, which means the estimated concentration will be lower. But it's generally pretty easy. I mean, I think the less than was pretty obvious to most of us because it's like, you add water to something, the concentration goes down. So that's that part.
I had like an MCQ on one of my tests where it was like, what would happen if like you had a dirty fingerprint on your
I love those.
cuvette?
I love this because it always like shades the like hypothetical chemist who's doing the problem. Sorry, it's so funny.
Question.
I also love that it implies that like it's never like something that happens out of their control. It's always like, let's say someone smashes the glass on purpose. What happened?
Yeah. And I don't think you can take apart the FRQs. I'm
You
pretty sure
can't take it apart. You can't take out anything.
What do you mean you can't? Like
You can't like rip the test up or. Like,
oh no, please don't. Yeah, you can't rip pages out. No,
Yeah, don't do that.
Actually, the
Don't
second
do
you
anything
do
without asking your proctor. Don't do anything without asking your proctor.
Yeah.
But don't risk it.
don't. I'm pretty sure the second you'd rip it, like your exam would be
invalid.
invalidated. Yeah, they're
Yeah.
pretty strict on that. They will have you at the end of the exam. If this is your first AP exam, we'll be going over this in more depth tomorrow, but they'll have you, we were talking about this yesterday, they will have you literally seal your test booklet shut when you're done.
Mhm.
Like, they really care about test security.
My
So if you've,
favorite
like,
sport.
So if you've like ripped a page out, like that to them is not just like, oh, I freaked out and ripped a page out. That was like they were trying to keep information about the test outside the testing environment. Yeah, I mean you're allowed to get extra paper, but like you won't need it.
You
And
can get
also,
extra paper,
don't-
and like the FRQ like booklet where you like write your answers is separate, I'm pretty sure, from your test. So
That's kinda
like,
how it was.
yeah,
Also,
that's how
be
it was for
careful.
AP Bio. So
make
Be
sure that
careful.
you're just answering the question. Don't try to like go on above and beyond. Just try to answer the question straightforward. Just make sure you're like, just answering the question. If that makes sense, like so that you don't waste time.
Yeah. And also actually, because you're writing this on separate paper, make sure to label your answers. Like write out A, B, C, so that your reader knows. Technically, you like don't have to do this, but you should. You really should.
and you can also like skip lines in between, but like, yeah.
Yeah, be clear on what question you're answering.
Oh, did we have a survey?
Oh, we do. Do we have the link for it?
Oh, did she send a link?
Do we have a survey for tonight?
I think there might be a survey sent out in an email after. That's what they did last time.
Okay. Unless there's someone here who can give it to us. Yeah, thank you. Yeah, we have a survey just for all the answers just like last night, but we might not be able to find it. So we're doing our best. I'm trying to think of other just like broad FRQ tips. Box your answers. Box
Yes.
your answers. I just remember this. If you, let's say, like have written out 3 answers and you don't want your reader to be confused, circle 1. They will pretty much pretend that all other answers don't exist.
Also,
circle
make
your
sure
answers.
that you're doing all these like things we're telling you to do when you're practicing too, just to make sure that you're like you're in the practice of you doing all these like precautions.
Oh, sorry, the fingerprint thing. So, the fingerprint would show an increase in absorption because the waves cannot like go through it because of like the smudge in your fingerprint. But it wouldn't do anything to the concentration. It's
It
just
would change the
it's just like
estimated
your
concentration,
error,
though.
yeah.
It would change the answer based off the spectrophotometry, but it would not change the raw true concentration.
Yeah, it doesn't change like the actual concentration, but like the reading will show it has a higher concentration than it actually has.
Yeah, that's the important part of this question, where some people were like, why can't I just say adding water decreases the concentration? It's because it was asking how does it change the estimated concentration. So we were asking after the absorbance.
If it decreased absorbance, that means more wave, like the light waves would go through, but it's blocked by the fingerprint, so it's increased in absorption.
Yeah, less light is basically absorbance is described by we have some amount of light coming into the cuvette and some amount of light coming out. The more light that passes through, the less is absorbed. And so if we have perfect absorbance, we have some amount coming in, if we have none coming out, that's perfect absorbance. If we have less coming out, it's higher absorbance.
You can box the answers.
Yeah,
box
like
the answer,
should.
not the work. Box the answer.
The answer.
Yeah.
Also include correct units. Be very careful with your units and intentional with your units.
I also believe the survey that's going to be sent out tonight, you can like say like what you want reviewed and all of that, and then we'll review those tomorrow.
Yeah,
Don't stay up the day before the test taking practice exams is not gonna help.
You're gonna burn out, and it's not good to burn out.
It's not. Well, and you probably are gonna do fine.
Yeah, I think personally, don't spend. I'll tell the story. The night before my AP World exam, I got home from school at like 3 p.m. and took a nap. That's all I did all day. I straight up got in bed and took a nap. It was awesome. Don't study the night before because, and we'll talk about this tomorrow. It doesn't help. We'll give details on that tomorrow. Also, I mean, you can underline your answer, but boxing or circling is like the standard. If you underline something, they might just see that as like emphasis.
Yeah, if you want to stay up late tonight and not tomorrow night.
Yeah, tonight, not tomorrow. Make sure that you're actually sleeping for the test, because it's not worth it. Do you know, like, I know on the Fireball site, you guys might have seen our cram sheets.
Definitely
Mhm.
use those.
Yeah, if you really don't feel prepared, or if you just don't like feel confident, you probably would like you guys can just like look at our cram sheets for AP Chem. I think it's just all of AP Chem summarized into one sheet, and I think it's pretty helpful if you just like just look at it and review that. If you really want to just read through it, if you really want to like do something like right before the test, just looking at that. But otherwise, don't like do any hardcore studying right before the test, like in the morning or the night before, because it's not worth it. Just like
Yeah.
if you really want to do something, you might as well just like read through that cram sheet. But like otherwise, I wouldn't suggest.
Yeah, and obviously, like our cram session tomorrow is just to like go over last minute questions or anything. Like tomorrow, you shouldn't be like, oh, I have no idea what unit 8 is, acids and bases, so I'm just gonna learn all the content. Like, you shouldn't be doing that tomorrow.
Tomorrow night will not be like a content night that big. It'll be like bringing it all together, but unless you guys explicitly ask about it, like we don't have much content heavy stuff planned.
Yeah, it's
Um,
mostly questions, and then like if we wanted to go over like FRQs, we can go over an FRQ.
Yeah.
Shreyas took the exam last year, I think.
I took it 2 years ago. I took it
2 years.
the year after. I took it 2021. I'm not sure. Yeah, I took it in person.
Wait, so that was last year.
2021.
2021 was online,
I think so.
I think.
I think 2020 was online. Right? Am I getting this wrong?
2021 was online because I took it in 2021.
yeah. Or was it there was like an online and paper, right? There were two different
Yeah,
exams.
in paper. I think there are two, and I took it in paper.
Are they all on
Oh,
paper?
okay.
Are they all on paper now?
Yeah,
Yeah.
they're all on paper now. Although
Nice.
I think
what
they're
I
trying to
know.
digitalize some exams now.
Oof.
Like AP Lang at some locations is online.
But is it like you're taking it on a computer altogether simultaneously, or is it like you go
I
home
think
and
so.
take it? Okay, that makes more sense. I love paper exams for like Chem and Calc. I'm sorry, I took Calc AB on the computer. It was terrible.
How do you even do that? Like calculating on a computer.
So I wrote it out on like a piece of paper, and then I had to take the class. I had a desktop computer for all through high school, and my mom let me use like her old iPad for the exam. So I pulled it up on this iPad and was like taking pictures like this, like literally hovering over my work. It was terrible. Also, Nini, you asked a good question. You can take an exam 2 times. I would recommend not. You're
I
allowed
did
to
it.
take.
It's okay. I did it.
You did? Okay. It's not bad. In personally, if you get like a better score, great. I just don't think it's not like the SAT where like you're encouraged to take it more than once.
Third time taking AP Chem.
Dang.
Committed. The only reason why I was taking AP Chem again was because I tried self-studying it over COVID, and then like I kind of gave up halfway through because like 1, it's COVID, and 2, I don't recommend self-studying AP Chem. But yeah. The digital APs, I definitely don't do that. How the digital AP worked was for the MCQ, you couldn't go back.
That's
Like
right.
you only could like, so once you answered a multiple choice question, you couldn't go back to it. And plus like the time was like constrained even more. So like you didn't have time to just like look it up. Oh yeah. And the survey was emailed to you guys, so definitely answer that so we can find out what to do for tomorrow. And I do think time is up.
I was gonna say we're hitting up on 10, so I think it's time to wind down.
I hope you guys have a good night. Don't stay up tomorrow night. If you really want to stay up tonight.
Don't stay up tomorrow night. And no, we have a lot of Cram resources in our Cram Finale Hub and just on our website.
Yeah, definitely practice those FRQs. They're on the College Board website. But yeah.
Awesome.